All right, so what we're looking at here is transformations, okay? And what we mean by transformations, it's a process which changes the position, size, and or possibly the orientation of a shape from its pre-image, okay, the pre-image to its image. Okay, so all that means is we have a process of changes happening with the original figure that we're looking at, in which those changes from what the figure we start with, its pre-image, to the image that we end up with, the actual image, or the after image after we make all the transformations, okay? And now to kind of define what that means, when we say pre-image, we're talking about the figure before a transformation, and then an image would be the figure after a transformation. Okay, so you can think like before picture and after picture, and then there's transformations that occur in between, okay, what we start with and what we end up with. And to kind of clarify, when we say orientation, what we mean is the arrangement and or order of points in a figure relative to one another. Okay, so thinking in terms of like the layout, how is everything arranged in the picture, okay? Now to help clarify the difference between the pre-image, remember the before picture, and the image, the after picture there, usually we'll label the points in the pre-image like our normal capital letters like A, and then the image would be A primed, okay? So that apostrophe there would be A prime. That would be the after image, okay? Now, all of these guys here that we're going to be talking about, translation, reflection, rotation, those guys are considered isometric transformations, okay? Rigid motion. What that means is it preserves the distances and or angles between the pre-image and image. Or another way to simply say it is it maintains the size and shape of the image, okay? So no matter what we do to that original image, that pre-image, what we start with, it maintains the same size of it and the same shape of it, okay? For instance, when we're talking about a translation here, we'll write out the formal definition here in a second. Notice in example number 2, it's called a slide. A translation essentially means we slide. So we're sliding the points in some direction. In this case, these points all seem to move to the right. So when we translate something, we're talking about we're moving the entire image, we're sliding it. We don't change the image, we're just moving it, okay? And then the next one that we see that we're going to define here is called a reflection. Well, we kind of talked about a reflection when we were talking about line symmetry, okay? A reflection is just going to give us a mirror image or a reverse image. Like this guy over here in example 3, we get a mirror image, okay? If we can think of it in terms of our line of reflection again, notice if I flip it to the other side, fold the ends, they would match up, Okay, and then a rotation, we kind of talked a little bit about rotation before too. All that's going to do is kind of change and rotate the image about some point. Okay, so it doesn't change its shape, size and shape, but it rotates the image. Okay, all the points are going to rotate around some point. Okay, now the formal definitions we want to write out here is a translation, a transformation, that slides each point, in a figure a given direction and distance. So it moves at a certain direction and distance. Like we said over here, this guy appears that it moved to the right, and even though we don't have a judge for distance here, it moves some distance. Okay? Then a reflection is a transformation that flips each point in a figure through or across, a given line. Okay, so we kind of talked about, similar to that idea of thinking of the line of symmetry, it flips over some line, okay? And a rotation is a transformation that turns each point in a figure through a given angle around a fixed point. So as I was kind of alluding to earlier, there's some fixed point that we rotate the image around. Okay, so there'll be some kind of fixed point that we rotate the image around. Okay, now these guys will work on together in class tomorrow. We kind of talked about what the transformations are. Okay, now I want to kind of move on and talk about, those were isometric transformations. Let's move on to the non-isometric. There we go. The non-isometric transformations, okay? In other words, isometric, we maintain size and shape. We didn't change the image. We maintain size and shape. When it's non-isometric, it does not preserve those qualities. It does not preserve distance and angles between the pre-image and the image, okay? So these are the examples we would deal with that do not do that. A dilation, okay? A dilation, essentially, we can expand the image or shrink the image. However, it does maintain the shape of the image, okay? So it doesn't maintain size, but it does maintain shape. Everything is proportional, okay? What doesn't maintain the shape is when we do a stretch, okay? We can stretch an image, we can make it bigger, but notice if we look at these two images here, an example and example 2, in example 3, it doesn't maintain the shape, okay? So it stretches the image, but it doesn't necessarily maintain the shape. So those are the two that we can deal with that are non-isometric, okay? So a stretch is a transformation that changes the dimensions of a figure, okay, at different rates. Or like I said, it just doesn't maintain, even though it doesn't maintain the size, it also doesn't maintain the shape. So it doesn't maintain either quality there. A dilation, however, it does change it at the same rate, so it maintains its shape at least. So a transformation that changes, and that should have an S, all the dimensions of a figure at the same rate. In other words, it doesn't necessarily maintain size, but it does maintain shape. Okay, and we'll go over this part tomorrow. What I want to look at is one example of these, and then we'll move on to the composite notes. So you can also talk about transformations in terms of taking points on a coordinate plane and then assigning them or mapping them to a certain destination. So like in this image here, it says we have A at a negative 1, 1. Okay, negative 1, 1. We have B at 0, 4, 0, 4, and C at 4, 1. Okay, so we have those guys already put in our pre-image. Now, what they're giving us is a rule, a mapping rule, or they say a coordinate rule that tells us we want to take each point in the pre-image and then map it to its image, okay? Well, look at the difference between what we start with and what we end up with. The big difference here is this. In the pre-image, we have y. In the image, we have negative y. All that means is we're going to multiply a negative to each y, or in other words, each y is going to change its sign, okay? So if it was negative 1 in A, x is still going to stay the same. X doesn't have any change to it. X is still x. However, y is now going to be a negative, so instead of having a 1, we're going to have negative 1. For my x, remember it doesn't change, but for my y, it's going to be a negative. We're going to have a negative in front of it. So in my from my pre-image to my image, man, I'm mixing up my words here. We have a negative 4. Okay. Then again, my x doesn't change from my pre-image to my image, so that'd be 4. But from my pre-image here to my image here, it's going to be negative 1. Okay. So that's what this mapping rule is saying taking all the y's here. And then when we move it to the image, it's going to have that negative. In other words, all the signs were going to change. So all these positives right here became negatives. Okay. Now, let's actually graph this out here. We have a negative 1, 0, negative 4, and then 4, 1, 2, 3, 4, negative 1. Okay. So this would be my new image here. Or I should say my image. Okay, so notice when we look at this guy here, it's asking us, is this an isometric transformation? In other words, did it maintain its size and shape? Yes, it did. That is an isometric transformation. And actually, if we kind of look at this, notice, even though my picture isn't 100% perfect here, what we really end up with is a reflection from what we started with, okay? If we look at the original points, the pre-image points, we had a negative 1, 1, 0, 4, and 1, 2, 3, 4, 1. Isn't that just a reflection? Yeah, it flips over the line, right? So the type of transformation we have here is it was a reflection. Okay, so this guy right here was the pre-image, and then after we mapped all the points, this was our image. Okay, and it was an isometric transformation because it maintained size and shape, and it was a reflection over this line here. Okay, so I wanted you to be aware of that, and we'll go over these guys again tomorrow and then other examples as well. Okay, now I'm going to step out of this and go into composite transformations, the other part of the notes here. Okay, I'm going to go to composite transformations. So with composite transformations, all that is more than one transformation on the same figure. Whoops. Okay, so we have more than one transformation occurring. Okay, so we talked about translation, reflection, rotation, stretch, dilation. We have more than one thing happening. Okay, now we're going to do the majority of these hopefully together, but it wouldn't hurt to look at the first two here. Notice my image, A here, and then I have my pre-image. And then even from that, I have another transformation happening. So then we have a pre-image for my pre-image, okay? So we have more than one transformation occurring here. A primed, and A double primed. Well, what has to happen to go from A to A primed? Well, that looks like a rotation, right? So the first thing I notice, the first transformation I notice is a rotation. It looks like we turned the picture to go from A to A primed, right? Then how do I go from A prime to A double primed? Well, it looks like it got bigger. Does it look like it distorted the image at all? Did it maintain essentially the same shape? Yeah, it maintained the same shape. It doesn't look distorted, so I'd call that a dilation. Okay, so to get from A to A prime to A double prime, we rotated it and then we dilated it. Okay, what about if we're looking at number 3 here? How do I go from F to F primed? Well, notice if I draw a line of reflection here, doesn't that look like a reflection? Yeah, so the first transformation that I have here is a reflection. Then what about from F prime to F double primed? Well, again, if I draw a line of reflection here, doesn't that look like a reflection too? Yeah, it does. Okay, so the second transformation is also a reflection. Okay, so in this case, it just was an interesting example where we reflected it once and then we reflected it again to get from F to F prime to F double prime.